Yeah, so my name is Derek. By day, I'm the Director of Development at OrderSlip. We build apps for small restaurants to have mobile ordering. By night and all of my other free time, I do things like co-found a hackerspace, which to my knowledge is the only one between LA and the Bay Area, which is kind of cool. I'm on the board of directors for an organization called 59 Days of Code. We do a lot of tech education and trying to grow the technology scene in the Central Valley. And then I also run my local Fresno Python chapter. All of the slides, as well as the code that we're going to take a look at, is online on GitHub, bit.ly/Kivy-DjangoCon. Definitely recommend checking that out. Grab a picture, look it up, follow along. There'll be some URLs in there as well that you can check out as we go through the talk. So I'm not a mobile app developer. My whole background is web development. I've been using Django since 0.95 or 6. So that's kind of where I'm coming from in this, right? I've been using Python for quite a while. It's a language that I really like. But when I lived in San Diego, there's a classical radio station called KUSC based out of LA. And we live just outside of their broadcast range, right? There's this one hill in Escondido where there's a Target, and in the parking lot you can get this classical station. But so KUSC, they stream online. They didn't have a mobile app. They also didn't have a mobile friendly website. And I thought to myself, this is a solvable problem. I can do this. And so I dove in, started learning Android, and I put this together. This was just something to scratch my own itch. Grab their MP3 stream, play it on the phone, script their website once a minute to get what's now playing. It was native Android, XML layouts, and so forth. But there was a problem. And the problem was that it wasn't enjoyable. I've been doing Python. I love Python. I've been a part of the community. That excitement that you feel when you're learning new things, when you're building new stuff, it wasn't there for me. And I'm not trying to knock Java or native development, but the problem is that I really like Python. And ultimately, I want to build software that runs on my phone, but I would also prefer to build things with Python. So that kind of leaves me figuring out what options do we have? What are the options that we have? And the first one that I have to mention is the Beware project. So Beware is a project aimed at building applications in Python across multiple platforms using native UIs. You should definitely check it out. Beware developers are here at DjangoCon. Russ Keith McGee, Philip James, Katie McLaughlin. They're going to be sprinting on it. Definitely seek them out, ask them questions, learn more about the Beware project. And that brings us to Kivy, which is a framework for building multi-touch applications across platforms. So it's all geared towards multi-touch. It's not specifically mobile development. You can build something that runs on your phone. Yes, of course. Pinch to zoom, all of that is there. But it's also for things like if you need to build out a kiosk running on a touchscreen TV. That's a really good application for Kivy. Kivy is open source under the MIT license, and it's cross-platform. Runs on Android and iOS, also Windows, Linux, Mac OS, what have you. And Kivy is pretty fast. And it's fast because of Python, right? The bulk of the bottleneck in developing mobile apps with Python isn't your application code. It's going to be the graphics and the rendering. And so Python kind of bridges that gap, allows you to add static type definition or declarations to your Python code, effectively compiling it into C, and then you're basically just running C at that point. So we'll do a quick little demo. And kind of take a look at what Kivy looks like. There's tons of examples in the Kivy code base. And we're going to look at one, the Kivy catalog. Kivy catalog is just a collection of different layouts and widgets kind of showcasing what Kivy looks like. These are all Kivy widgets. With Kivy, you're not building native UIs. They have their own UI layer. But you can do things, different layouts, box layout, stack things up, put them in a grid. There's different things you can do with buttons, kind of showcasing different buttons and events there. Things like progress bars and sliders. All of this implemented kind of in an extensible manner and available to use. Now, the Kivy UI is not super exciting, very grayscale with some blue accents. And it's totally customizable. You can change all the colors and whatnot. But maybe you want something a little more complex without having to put a ton of work into it. And that is where there's a project called KivyMD that implements material design in Kivy. So if something like this is more up your alley, there's a lot of material design widgets included with this, all styled according to the material design spec. Everything, buttons. Again, a lot of the same things that you see in regular Kivy menus. It all looks decent and is a way to kind of give you a good starting point for building out more of your app's UI. And with that, we kind of go into looking at the code. So this is where it becomes kind of beneficial to follow along. The first thing that we need to do is install Cython and Kivy. The specific versions of Kivy work with specific versions of Cython. So you want to make sure, look at the documentation, see what version of Cython you need. There's other useful but optional dependencies as well, things like Pygame. So remember, when Kivy implements its own UI layer on the desktop, it's using Pygame to draw the window and write to that canvas. And this is our first hello world. We have 7 lines of Python that display hello world. Not a whole lot of excitement going on here. Very simple, just writing some text onto the window. 7 lines of code doesn't get a whole lot simpler than that. First thing we want to do as we step through this is import the app class and the label widget. Your application must inherit from the app class. You need to implement a build method that returns a single widget. This is the root widget of your entire widget hierarchy, the widget tree. And then we run it. Not a whole lot going on here besides that. Now, Kivy is meant for multi-touch uses. So it makes it really easy to do interesting things with zooming, rotating, scaling, and so forth. So looking at this example, same thing. We have hello world displayed in the window. But we can also set touch points and play around with the text a little bit. So this is kind of the core of all of the multi-touch interactions on Kivy, is this thing called the scatter layout. This is how it implements those multi-touch functionality. So the same thing, import the app and the label and the scatter layout, only this time we're going to instantiate the scatter layout. We have our label, we're going to add that as a child onto the layout and return that layout. That's all we have to do to get some neat multi-touch functionality into our app. And anything can go into a scatter layout. Events. So we don't just want to show things on the page. We want to allow people to interact with buttons, right? What do you do when you press a button? What happens next? The code for this slide is a little too long to look at once on one slide, but what we can do, and kind of showing a demo, we have a button that gets rendered to the very middle of the window. The button says click me. When we click the button, we have a pop-up that has another button that says close me. Very simple event handling here. What we're going to end up doing is importing the float layout. So the float layout works very much like CSS in terms of positioning. We also want to import the pop-up widget. Going into our build method, we instantiate the float layout, create a button. The size hint and the position hint do exactly what you would expect. We add the button to the float layout, and then we have this pop-up. Now, one thing that you might notice in here, as we define the pop-up and the button that goes inside of it, we're not attaching the pop-up to the float layout. And the reason for that we'll get to in the next example, but it's something that I wanted to point out here. The event handling itself is pretty simple. We have the open button, and we want to bind the onRelease event to popup.open. And on the close button, we want to bind the onRelease event to popup.dismiss. And then finally, we return the layout. Now, as you build out your Python app, doing all of your widgets in Python, as your app grows and becomes more complex, doing all of this stuff in Python can become a little bit messy, very verbose, and can be kind of tough to navigate. So Kivy tries to solve this with the Kivy design language. The Kivy design language is a very YAML-esque language where you define the tree of your widgets, and it uses that to instantiate the actual Python objects. So now, in our main.py, this is all the Python that we have. We have 5 lines of Python. There's nothing in our demo app, and we just run it. And we have this demo.kv, right? Very YAML-esque. The name demo.kv, the name of your kv file is derived from the name of your application class. So we have demo app, we get demo.kv. This is the same hierarchy that we had before with the buttons, the pop-up, the buttons inside the pop-up. And as we go into the specifics, we see the same attributes, the size hint, position hint, onRelease. What we're doing with the onRelease now, from within KV, we can access the root widget, look up the pop-up by ID, and call open on it. Now, an interesting thing to keep in mind here is that everything to the right of the colon is valid Python syntax. You can use data structures, lists, tuples, dictionaries, list comprehensions. You can call functions. You can do math. There's all sorts of things that you can do. You can treat it as a valid Python expression. We have our pop-up, again, that we are initializing. Same attributes as before, with the addition of the onParent that we're adding. Now, just like the build method needs to return a single widget, that's your root widget, same with your kvlang files. You need one widget at the very top. So the pop-up currently is now inside the float layout, right? It has a parent. And that's not what we want. We want the pop-up to have no parent. If it has a parent, it's going to get rendered to the screen. And we don't want that to happen until we press the button. So all we're doing here is saying, when it gets parented, if the parent is the layout, just automatically remove itself from the layout, and we get the same functionality that we had before. Ooh, what did you do? And then, of course, we have the same button, same onRelease, look up the pop-up by ID, and dismiss it. So as you can see, updating our example 3 to work with the kvlang works exactly the same. We have something that's a little bit easier to read and understand. It works just as it did when we were doing everything straight in Python. So we've gone through, we have put an app together. And now we want to get it on our phone, right? So we've built a Kivy app. We need to package it for mobile devices. The answer to that question, how do we get from Kivy app to mobile app? On Android, Python for Android. So Python for Android is part of the Kivy project. It does exactly what it says. It packages Python apps for Android. It does only run on Linux, which can be problematic. The Kivy project does have a VirtualBox disk image with everything needed to run it. So Windows developers, Mac developers, there is a way forward. Similarly, on the iOS side, there is Kivy iOS. So it's a toolchain for compiling Python apps to run on iOS. Same problems, obviously. You are probably aware that you can only package iOS apps on a Mac. So you kind of run into the situation where you need the specific platforms to build for those devices. But you shouldn't use either of those. And the reason why is because if you use them specifically, now you have this whole build process for Android and a whole bunch of custom stuff for that, and then this whole build process for iOS and a bunch of stuff for that, and it can get really unwieldy. So instead of using those directly, you should use Buildozer. So Buildozer is a tool for creating application packages. It's another part of the Kivy project. You can build for Android and iOS using a common spec file. So you define all of your configuration and attributes in one place, and then go from there. It's really easy to install. Pip install Buildozer, and then run Buildozer init. Buildozer init gives you a default buildozer.spec file. And from what I've found out, in most cases, that seems to work just fine. I haven't run into any major issues with that. So the buildozer.spec file is basically just an INI file where you can configure the name of your application, the package domain, source directory, any other assets you want to bundle in. Also, platform-specific configuration as well, Android permissions, API versions, so forth. There's similar iOS-specific options for Apple devices as well. So when we want to build on our phone, we've filled out our buildozer.spec file, and now we run buildozer Android debug. What that does is it goes through, if you haven't already installed the Android SDK and the Android NDK and Python for Android, this command will do all of that for you in one go. So it's a lot to download. This can take quite a while to run the first time you run it, but once you've run it, once you've done it, now you have everything you need, and it becomes a lot faster as you start iterating on your app and testing on your mobile device. So this command will package up your APK file and drop it into a bin directory, which is nice, but you might want to run it on your phone to test. And so all you do is you tack on deploy run as an additional commands to that. And so deploy will then take the APK, use ADB, put it on your device, and then run will open it up. So you have one command to build your entire app, build the APK, put it on your phone, and open it up in just a couple of seconds. So building UIs is great. Phones these days have a lot of really neat hardware. You have accelerometers, gyroscopes, camera functionality, all phones vibrate. You want to do things with those. How do you do hardware things? And so the example that we're going to look at is the accelerometer. Enter Pygenius. So Pygenius allows you to access Java classes through the Java native interface. And the way that you do this is that you, for the accelerometer example, you have to build a Java class to interact with the Android sensor manager. There's a lot more code here than I can fit onto this slide. It's also Java. I don't know Java that well. So you have to build all this out in Java, create that bridge, and then on the Python side, import autoclass, instantiate it, enable the accelerometer, and you can go read from the accelerometer. Similarly, you have PyObjects for the iOS side. So PyObjects, similar to Pygenius, lets you do iOS or Objective-C things from within Python. So I'm not an Objective-C developer either. This is the example that's given. You have to use core motion on the iOS side in order to interact with the accelerometer. And then the Python side looks somewhat similar to how you would do it on Android, right? You import autoclass. In this case, we're going to instantiate the bridge, start the accelerometer, and we can start reading values from it. But we have another problem, is that I don't want to write Java. I don't want to write Objective-C. I just want to write some Python. And so again, we have another layer of abstraction that the Kivy project has provided called Plier. So it's platform-independent APIs for common hardware features. It supports a number of features on both Android and iOS. If you're not running on one of those platforms, say you're doing something on Linux or Windows, Mac OS, it will use available libraries on those platforms to kind of fill in the gaps. So if you have an accelerometer on a desktop or whatever Linux thing that you're doing, you can still do hardware things with Plier through one simpler interface. And so now instead of having to write a bunch of Java and Objective-C, you have 6 lines of Python with no platform-dependent code, which becomes really nice, right? I can just, import the accelerometer, enable it, go. I didn't have to dip into any platform-dependent code. So that's kind of the gist of Kivy. And I'm going really fast, wow. Kind of showing off, one of the reasons why I started messing with Kivy is I really like playing guitar. I'm really bad at playing guitar, but I really like playing guitar. And as I was going through, trying to learn, build up muscle memory, learn chords, there's this trick where you go from guitar chord to guitar chord, just kind of strumming chord to chord to chord, trying to build up muscle memory. And so a Kivy app that I put together is this thing called ChordWise, which is just that. So ChordWise lets you choose guitar chords. This is all a Kivy app. Choose what guitar chords you want to practice. You can select and deselect chords. And then dumps you into practice mode, sending them at you in 4/4 time at 100 beats a minute. There is audio. There's a little metronome that plays as well, so you can kind of keep time. And this has been kind of helpful for my own playing, trying to learn new chords and build up that muscle memory. And it's been a neat experience, right? Being able to build this, put it on my phone. I have it with me anywhere. There's a couple guitars at my office. I have my one at home. And I can just pull up my phone and start practicing using this Kivy app running on Android. So we can totally build mobile apps in Python. You totally should build mobile apps in Python. I would love to see the Python ecosystem grow in that regard. There's been a lot of efforts to doing interesting things in Python, both on mobile apps, things like in the browser. I would love to see Python everywhere. I probably like the language a little too much, but a lot of that has to do with the community and all the support here. So that's kind of it. Questions so far?
So once you've built your app, how do you get it to your phone?
Yeah, so that takes us back to Bulldozer, right? So all of that, getting your app onto your phone happens inside Bulldozer. This command, specifically this command, will build your app in debug mode. It will deploy it to your phone. It'll put the APK on your phone. There's a similar command for iOS, and then run it directly. So that's pretty much all that's needed. It's a single command to get everything up and running on your device.
Does Kivy require Python?
Yes.
Ah, okay. And then another question is, can you mix and match the Python and designer widgets? Like if you write your own widgets in Python versus that designer app that you show, can you mix and match those widgets?
Yeah, so you can obviously design your own widgets. And you probably want to do that if you want to make things extensible, right? You don't want, if you have a button with certain parameters, certain position, colors, and whatnot, you probably don't want to pass all of those options in to every time you instantiate that button. So of course you can, through object inheritance, define your own custom button and set those yourself and use those throughout your app.
Okay, I guess next question would be, in your plier example, I saw that you were using xrange. Does that support Python 3 or is that Python 2 only?
So this example, let's see, where's that example?
Right there.
So this code example is a little bit older. Kivy itself does support Python 3. Bulldozer, and so specifically Python for Android, it does have Python 3 support, sort of. I haven't been able to quite get it to work. You have to use a custom NDK for that. So I would say if you specifically are targeting Android, for now you're probably stuck doing Python 2. If you can get that the Christax NDK to work, which I wasn't able to, then by all means use Python 3.
Cool, thanks.
So it looks like everything that you've shown primarily is oriented toward user interface type work. Does Kivy support background services and other non-UI based applications?
I haven't had a need for that, so I haven't really come across it. So the answer, honestly, is I don't know. I'm afraid I don't have a better answer than that. I haven't come across anything in Kivy that is like background work. So
the material design demo you showed at the beginning, is that just how deep is that? I presume it's a theme. How deep is that theme? Is it just sort of a coat of white and blue paint, or is it actually changing behavior in any way?
So what they've done is the Kivy MD project, and I don't have a link in my slides, so I'll update my slides online. But they've created a custom set of widgets, right? So instead of button, you have MD button that you use throughout your application. So with this, you can absolutely mix and match regular Kivy widgets with material design widgets if you wanted to.
But they're actually material design widgets. They're not just Kivy widgets painted blue.
Yeah, so I'm not entirely certain about how they're set up kind of behind the scenes. I know that this looks pretty darn close to material design. And I'm not really sure what you mean by actual material design widgets, because MD is more of a specification, right, than here's a library to use in things.
So I was thinking more in terms of if I had an actual native Android application but with material design,
okay.
would I notice any difference whatsoever, however superficial?
Good question. We should test it out and see how close it comes.
Sure.
I know in using material design for web stuff, this looks pretty close from everything that I've seen.
Okay. Related to that, accessibility. What's the accessibility story with Kivy widgets?
I would imagine there isn't a very strong accessibility story there, simply because it is implementing its own UI layer, right? It's a canvas and it's just kind of drawing onto the screen. None of it is native, so I don't know how well you can tap into accessibility features on the platform that you're building on.
Sure, thanks.
So, yep.
My question is about push notifications. Like I use Firebase for push notifications in native Android and iOS. Is that anyhow supported here?
Yeah, so push notifications, again, I'm not super familiar with how they're implemented on native Android and iOS. I know that in my experience, like at work, we had to go through and like create a Firebase account and do all this weird stuff. I don't think that there's anything that would stop you from doing that. Again, because we have Pygenius and we have PyObjects, right? You can hook into any Objective-C libraries and call classes and whatnot with that. So I would imagine it's doable. There isn't anything out of the box in Kivy that provides that purely from the Python side.
Yeah, so I was wondering what's going on under the hood. Is it packaging the standard Python interpreter into the the application packages? Is it running on Jython under Android?
Yeah,
Is it
so-
on the JVM?
So
how does it work?
more or less, it's packaging. My understanding is that it's packaging CPython, right? And I kind of want to. I should have qualified this in the beginning. I am by no means a Kivy expert, right? I occasionally want to do mobile app development. I would love to do Python with that, and so this is kind of what I've discovered along the way as I've done a couple things with Kivy. So again, my understanding is that yes, I believe it is packaging regular CPython up to run on Android. Again, I'm a little light on specifics of how it's doing that.
Regarding Plier, you said that gives you access to the hardware. What kind of hardware? You showed one with the accelerometer, but camera or I don't know.
Yeah,
what else?
so the Plier project on GitHub, they have a table where you can kind of see what's available on what platform. So Android is, let me zoom in here. So Android is pretty well covered in terms of what you can access. iOS a little bit less so, and then it gets less as you go down into desktop operating systems. But there's a lot here that you can do. Things like the proximity sensor on Android, sending SMS messages on both iOS and Android. Again, Android is much more fleshed out in terms of what Plier supports than iOS, but there's a lot here that you can work with.
Hey, thank you. Really good talk. I just had a question. What are some good apps that have been made with Plier that you know about, alongside your code?
Sure. Yeah. So there was, and I'm a little bit bummed. I originally had a slide in my talk saying if you get bored, go download. Does anybody remember 2048? 3 is when that was all the rage. So there was a really cool implementation of that built in Kivy that was on the App Store. And in preparing for this talk the other day, I went to go, get it and add it as my slide, and it's not on the App Store anymore, which is super unfortunate because that would have been really cool. But I mean, searching for Kivy in the App Store will yield some results as well. They have a showcase on their website kind of showing what's been done with it. I've seen screenshots from several different games. There is an event library called Kivent, which is great for event handling, and it has been used to make some games in Kivy.
Well, in that case, thank you, Derek, for a great talk. Let's give Derek a big hand.